Swayam Prabha. Digital India. Educated India.
It is our privilege to welcome Professor Siva Athreya, an eminent mathematician whose contributions to probability theory and stochastic processes have significantly influenced contemporary research. Professor Athreya earned his BSc in mathematics from St. Stephen's College in 1991, a Master of Statistics from Indian Statistical Institute in 1993, and a PhD in mathematics from University of Washington in 1998. His research spans stochastic processes, random graphs, stochastic differential equations, and computational epidemiology, combining deep theoretical insights with impactful real-world applications. We are honored to have you here with us today, sir.
Okay, since it's early in the morning, let's do some exercise, okay? Okay, I want everybody in the odd position here to stand up. You're in the odd position, so you stand up. Every row, the odd position, I want you to stand up. Odd position. Okay, let's go. So this is okay, so just a few things about myself. So now what we'll do is okay, let's do the worksheet. This won't be like a lecture. So we'll try to do problems from the sheet. Okay, so let's see. So how many of you have played with the calendar? Can I have a quick show of hands? Like calendar month. You see the worksheet? No, open the worksheet. How many of you have played with the calendar? Have you looked at the calendar, stared at it for a long time? Nobody? What have you done? Very good. Okay, very good. Very nice. Okay, my class is over for you. But yeah, somebody else. Okay, very good. So okay. So okay, some ground rules we'll set before we start. Okay. So you all can see the board, right? Okay. So my name is Siva. Okay. You should call me Siva. Okay. If you call me sir, I will call anybody auntie. Okay. Is that clear? All my students will do that. Even Keshav, I've done that many times. Okay. So you call me Siva, I'll call you auntie. You call me Siva, it's okay. Call me sir, I'll call you auntie. How will you call me? Very good. Excellent. Well done. Okay. That's one ground rule. The other ground rule for this workshop is, today's thing is that there is nothing in the head. Okay, so you have to write your thoughts down. Okay. So while solving a problem, there's a lot of things going on in your head. I want you all to document it. Okay. Then I'll ask you to show it to your neighbor and discuss your thoughts. Okay. This can have various consequences. Long time back, one person wrote down, "I'm an idiot." It's not in the head. So that is not right. Only mathematical thoughts. Okay. Very good. Okay. Very nice. Okay, let's go. So let's go to the first. So we'll play with this calendar. I'll leave the calendar on the board on the slide. So you can. It's on the first page of your sheet, right? So now open the sheet. Go to the second page, and this is there. You can refer to this and then work on the second page. Let's go. I'll come around and help you. Okay. So the questions are self-explanatory. If you don't know, I'll come and explain to you. Okay. So page 2. Start filling in. Write your thoughts down. I want you to write thoughts down. Write thoughts down. Yeah, right. Anything, pencil, pen, paper, anything. Okay. Anything. Okay. Right. Anything. Okay. Just this is your sheet, not mine. I'm not taking it back. Write your thoughts down. Yeah. You talk to your neighbors around you. How come the 2 or 3 are sitting like this? What happened? Will you get up? 2 of you get up. Get up. 2 of you get up. You sit one there in the middle. Come and get up. Come. Sit here. No, I want my way. No, I don't want them to go there. I want my way. Get up, bro. You sit down. I don't sit down. Where you go? Come. Now you move to the middle. Sit there. Tell me, get up. No, what's going on? No. Come. You sit on there, like the gentleman said. Go sit there, next to her in the middle. You sit that side. Come. Go sit next to her. Go. Okay, very good. Let's go. So have you all finished the first question? How many of you tried the first question? Quickly. Have you all done? Should be easy, right? And talk to each other. I don't want quiet class. Just talk to each other. It's allowed to talk. You look at next door neighbor. Write all the rows. What do you write now? The first should be easy, right? What do you observe? Second, what do you observe in the first thing? So what do you observe? So second row is what? Second row is, like if I write down, is 2, 9, right? 16, 23 and 30, right? Correct? What's the difference? 7, right? So every row in the calendar has common difference. The idea is clear? Okay. So the first thing we observe, in the calendar month, every row has common difference. What about the next one? Column wise, what happens? How many rows have you written? Why only one? Write many rows, no. I can write many columns, no. Why only one column? Write down thoughts down. Yeah. How do every column has column 1? Check every column. I won't write everything. Yeah, let's go. Yeah. Write down. What happened? I'll put the calendar one. Calendars here. I'll put the calendar here. Calendars here. Don't look backwards. Calendars here. So every column you write down. One, this one, write the column down. This column down. Right. So quickly write down. I'm waiting. I'll show this to you. Very good. Looks like that. So you can use my board. But it should be easy to do. No? If you start a number, then it's 1, right? So calendar goes by 1, right? So 7, 8, 9. Okay. Very good. Very nice. So this we have realized that everybody in the column has difference 1. What happens diagonal? So how is 8? Very good. So if you go this way, it's 8, right? It's 1, 9, 17, 25, right? If I go this way, I get 6, right? So write down. I want all of write down. And also, like, see, everyone's writing the answer down, right? No one's writing any thoughts down. How do you get 7? How do you get 7? Or how do you write 7? Write down. No, we observe to write down. No one written thoughts down. So I would write. My notes would be the following. So observe, right? Observe 9 minus 2 is equal to 16 minus 9 is equal to 23 minus 16 is equal to 30 minus 23 is equal, something else you must write down, right? Okay, I'm writing the hand, not quite good. Something you must write down, right? Your thoughts down. Whatever you want to write down. Okay, I won't write my thoughts down, but you write down. This is and you can't write my thoughts. No? You write your thoughts. Okay, I wrote it my way. You should write your way. How you came up with 7, or how you came up with 1. Okay, so as you go higher and higher in studies, you must know how to write the thoughts down. Why will that help you? Can someone tell me? Revise. Revise is one thing. Revise is very good for exam. But generally, why will it help you? Tell me.
Check where we went wrong.
That's also very good. Keep track of what you're doing. Anything else? Anybody else? Right. So far, okay, very good. This is more about your own self.
You can teach others easily.
Right. You're memorizing. So what does not memorizing help in?
Teach others easily.
No, memorizing does one thing. You keep less in your head. Okay. Your head is finite. Okay. It can't keep everything in your head. As you grow older and older, you can't keep everything in your head. Something has a paper which you must look at, and only logical thinking must keep in the head. So it'll also help you break down bigger problems into smaller problems. Okay, that's why you write down problems. So if you start practicing writing down your thoughts for simpler problems, you learn slowly how to write down your thoughts for harder problems. Okay, so the problem is very, very hard. Your mind's not going anywhere. You can write thoughts down. Okay, let's go. Okay, diagonal 8 and 6, right? So we'll write down. So I'll write down one. Let's go here. So diagonal, I'll write down my thoughts quickly. So the column was 1. 2, 3, 4, 5, and 6. The difference was 1. Okay, and then here I'll say every column has the same. Okay, very good. Okay, so let's go to this one. The diagonal has 8 and 6, right? Depending on how you go, right? So one is if you go 2, 8, 14, that is 6, right? And if you come down, 1, 9, 17, that's like 8. Okay, very good. So now how do you do this one? Can you find the mean and the average? Anybody know how to do this? Like I look at the first row, right? The first row is this person right here, right? Without doing anything, can I find the mean? Middle guy. Why did you say that? Why did you say middle? Anybody? Yeah, how do I verify that? Do you know? So he's used the word AP. What does AP mean? What does it mean? No, that's a full form. What does it mean? So, so can someone make it precise? Like, can you? I'll give you 2 minutes. You make it precise. This idea that when is it middle? Odd number of terms is middle, right? That's what you think, right? And even number of terms, what happens? Okay. Can someone make it? Can you think about how will you make this precise? These two ideas. The two ideas you have are that even number of terms means odd number of terms means the middle chokra is the mean. Okay. Even number of terms means you take the here. In this case, these two average will be the mean. That's what someone has said till now. But can you make it precise? How will you make it precise to somebody? This generic statement. If I take an arithmetic progression, odd. Let's go odd first. Arithmetic progression with odd number of terms. The middle guy is the mean. How will you make it precise? The answer is correct. How will you make it precise? Write thoughts down. Write down. I won't write thoughts. I'll wait 2 minutes. Huh? Just write down your thoughts. And write down your thoughts. Unlike me, write down in complete sentences. So you can go back and read it also. Auntie, tell me.
Sequence of n terms, the n by 12th term is, and if n is odd, the n by 12th term is the mean,
Why?
because that's the term.
Why? I'm asking why. That fact I agree. Why? I'm asking why. Write down your thoughts now. Where's written? Don't write down your thoughts now. I'll come and check. Whatever you want to say, you write down. I'll come and check. Write down thoughts down. If you call me sir, I will not come to your table. Huh? Okay. So let's see. I'll help you. How to write thoughts down? Okay, since you're all struggling writing thoughts down, I'll help you. Suppose I was your age. I mean, that may be unfair because I may not be as smart as you guys. But let's see. I will not spend my summer in IIT Madras. But it's okay. Okay. So what I would do? Okay. So suppose. So now let's take the first row. So there are. I'll take this row. Let's see. You can't do this, but I will do this. Okay. So. Oh, very good. So this is my row 1, right? This is my row 1. Very good. Okay. Okay. So what I'll say is that how many terms are there? There's 1, 2. So I'll call this the 0th term, right? The 0th term, the first term, second term, third term, and fourth term. Right? That's the first thing I'll do. So I'll just say n is equal to 4, right? And wait.
None of you are getting the point. He's not going to give up on this. You should also just adapt.
Okay. So very good. So what is A now from the book? What is A? Arithmetic progression. You write some A plus something. What is A? A is the first term, right? A is 1. The common difference is D is 7, and everybody in the sequence looks like A plus. So I would just write it as K minus 1 times D, right? Or KD. I would A equal to KD, right? Where K is equal to either 0, 1, 2, 3, or 4, right? This is how I would rewrite my box, right? Okay, correct. So this is how any AP would look like, but for my example, this is how it looks like, right? Very good, right? So now how do I find the average now? What is average? Can someone tell me what's average? Write the thoughts down, yeah? Don't look at my face, yeah? Come on, let's go. What is average?
Sum of all by number of.
Very good. So okay, after this, if you've spoken once, you can't speak again, okay? Okay. So far, if you've spoken easily, you can't ask a hard question anymore. Okay. So how do I add the terms now? I'll take summation, right? I'll do this way, maybe. A plus 0D, right? A plus 2D, right? And I'll just leave it like this. I will write it in my term A plus n times D, right? If I have n term, but here I know what n is, but generally I would do this, right? In AP, correct? And I have to divide by. Wait, yeah. Average, right? Right, this is clear? Yes? Now let's try and simplify. Now from here, can you show me that the minimum is the middle is the average for the odd guy? Show me. Let's see.
There's no A plus D. It's only A plus 0.
Thank you. Very good. So I'll put a dot dot. Very nice. Thank you. Pay attention at least. Very good. Okay. How's that? So that's okay. Okay. Now let's go. Very good. Now, maybe it's not good. Let me write this. So how will you find the average of this guy? How do you simplify it and tell me that the middle term is the, let's say n is odd. N is odd. How will you find that? How will you tell me that middle term is average? How will you find? How will you do it? Or n is, in my case, n is even because here there are n. So for example, there are n is actually 5, right? N is actually 5, right? So here k is equal to, yeah, n actually is 5. Not 4 because there are 5 terms, right? 0, 1, 2, 3, 4 is 5 terms, right? So, and so here I have to have, so n here, okay, I put n here, n is 4, I have to put n plus 1 here, right? Because there are n plus 1 terms, right? Okay, now tell me how to do this now, tell me. How will you simplify this? Very good. So some people observed already, let's put all the A chokras together, right? All the A chokras. So let's call them, let's color them, let's say orange. Okay, all the A people, there are how many of them? How many of them are there? N plus, each term has an A, there are n plus 1 of them, right? So I'll have this equal to n plus 1 times A divided by n plus 1. Very good. So, and then plus, let's do, what about other guys? What do they have in common? They all have D in common, right? D, all this has D in common, right? So, they all have D in common, right? So I'll have D times, what will I have inside the D? Be careful, right? Write the thoughts down. Don't scream, write thoughts down. So what I'll have is, I'll have 0, I'll have here 1, right? So I'll have D into 0 plus 1 plus 2 all the way till n and divide by n plus 1, right? So now all these boring questions in IT entrance exam, what will happen to the sum? Very good. So this first term, what will I do? I'll cancel, right? I'll cancel the n plus 1 with n plus 1, right? I'll just get equal to A. This person I'll get D. The blue part, the top, I'll get n into n plus 1 by 2, right? And I have a 1 over n plus 1. I will cancel the n plus 1, right? And what do I get now? So I get A plus n by 2 times D, right? So that is the middle term, right? If I have I have 0 till n, I have n plus 1 terms in my sequence. The middle guy, if n is even and n plus 1 is odd, n by 2 term is the middle guy, right? So this is an actual idea, way of quantifying that in an arithmetic progression, the middle person will always be the mean. That's what I mean by writing your thoughts down, right? Write this down, what I said just now. What I say just now. Write it down, quantify your thoughts now. After that, I'll come and quantify. Very good. Very nice. We've done one proof today. And tell me, so I'll write my thoughts down. You should see if you write same way, okay? So I will write thoughts down. The idea is that, so if there are, if there are 0, 1, 2, n terms in an, I'll use the word AP like you all use, arithmetic progression, then n by 2 is the middle term. Terms index, right? So this calculation on this side implies that the average of n of let's say I'll just call it 0, 0, 1, 2 up to n. So here I'll write one more thing: when n is odd, when n is even. So n plus 1 is odd. So n is even. There are n plus 1 terms. So this is equal to the middle term. At least this you must have written down. Okay, if you have not written down this, that means you're not writing your thoughts down. So this is something you must develop. It may not help you in your entrance exams or competitive exams, but as you grow older and older, it will help you solve things properly in a methodical manner. Okay, very good. Okay, now this part, page 3, I want to do quick. No thoughts, just do quick. Page 3, just do quick. 4, I need more time. Okay, because I want to finish by 10 o'clock and I want to do the next one. 3 is quick. Let's go quickly. How many of you know what a magic square is? Okay, very good. If you don't know, very nice. The question will tell you. Read slowly and I'll give you some time. So you understand in the calendar there's no magic square means what? Everything is the same, right? The row sum same, column sum same, diagonal sum same. They are very, very special. Where have you seen magic squares? Has anyone seen magic square before? Not on computer, not like I have presented. In real life, have you seen a magic square anywhere? No one has seen a magic square anywhere? I'm amazed, yeah, okay. So there are many places you can see magic squares. I'll let you Google and check. Okay. But you must go out and check. When somebody presents you a mathematical object, you must always check where it came from. Okay. Some are intrinsically just sort of mathematical objects, but others. Let's do BC. Let's finish. BC. Go. Let's keep going. BCD. Write your thoughts on. Huh? Auntie, tell me. Huh? Sudoku, I don't know. I don't think so. I don't think so. It is? Every row has one. Diagonal, I'm not so sure. Auntie, sums are all the same. Yeah. Let's go. I think I've heard this. I have not checked it. A lot of this astrology guys, when they do some jing check with planets and things like that, they're all magic squares apparently. They transform one magic square to another magic square. That's all that's going on. Okay. If you have heard this, I have not checked it myself. Okay. See, so in a calendar, there's no magic square, but there are fun things that happen. For example, if you take a 2 by 2 thing, what do you observe here? In this thing, what do you observe? What do you tell me? What do you observe? Diagonals are same, right? So in the 2 by 2 case, the diagonal will be the same. This is like in the 2 by 2 case, this will be like 22, right? And this will be like 22, right? So that's clear. But the other guys are not the same, right? Because this person is like 15, right? And this one obviously will get added by 14, right? Because we know that the arithmetic progression is 7, so we add 2 of them and go by 14. Right? So it will not be the same. And similarly, row will be different, right? The row will be like 21 here, right? And this will be like, again, you're going to go up by 2 because each one's going up by 1. It will go by 2, right? So in a calendar, the one magic, not complete magic square, the incomplete one, diagonal same. In a 3 by 3 case, you can do fun things also. So can someone spot in a 3 by 3, what do you see? If I take a 3 by 3 subsquare of a calendar month, what do you see? What are the same things, do you know? Diagonals may not be the same, right? May not be the same. Maybe the same, maybe the same. Yeah. So diagonals, okay, one claim with diagonals. Let's try that. Let's go here. What is giving, this is giving what now? What is giving you 3 plus 11 is 4. Write the thoughts down here. Write the thoughts down. What's going on? No look at my face here. Okay, right. 23, right? Very good, right? And this side is what now? 30. Oh, 30. Thank you. Very good. And this is 33 as well, right? That's quite cool. So the diagonals sort of maintain their sum. Is there anything else that maintains? Can someone tell me anything else? So like I've said, right, if I take the 3, the 5, the 19 and the 17, what do I get? 44, right? Yeah. The four blue ones, right? I get 44, right? 4 blue ones, 44, right? Okay, that's the corners, right? And let's say I do the middle guys. Let's do a middle guy, let's take green. The middle guy I take 4, right? Plus 12, 16, 34. This guy is 44, right? Correct? So middle guy also is 44. So the middle sums are the same as the corner guys, right? Something funky is going on in the calendar. Because I'm arranging numbers in an arithmetic progression, there's something more deeper going on. I will not come to that, but the diagonals are the same, and the thing is 44, and they differ by 11. This you should check later on if they're the same here as well. Okay, I will not do this, but check later on. Okay. Very good. That's another. I didn't do that. Let's do that. Very nice. Let's do that. So let's go here. Let's take some of the. I'll go pink. Let's say. So if the observations are following. If I go here, what do I get? I get 33. The same as diagonal, and this is all 33, right? 24. Very nice. That's a good observation, right? So you can. So if there's some symmetry in the square that you pick around a certain point, these structures will occur. Okay. But there's something else going on here, but I will not. I don't want to sort of elaborate on it too much. Okay. Okay. This 4x4, I'll let you play with it. Okay. Now I want you to play a location game on next page with the person odd and even. Okay. 2 people. I want you to play that game. Number 3. Don't look at number 4. Number 3. I want you to play the game with the person next to you. So what you'll do is, you'll pick a number, and you should be able to tell which row the number is in some sense. The sum will lie. Right? So pick 2 numbers in 2 different rows. I add them. You must be able to tell me which row the sum will lie. You talk to your partner next to you and discuss. I'll wait. 2 minutes. You understand the question, right? The question, understand? Okay. You can play the 2 numbers first, and then write your thoughts down, discuss with your partner next to you. Just chat each other, discuss. Yeah. Auntie, tell me. I didn't say that. No, 2 rows. Pick 2 rows first here. I said that, no, first line. Tell me, auntie. This was also. Yeah, use the first page, The calendar. Use this page, So you can use page. I put here on the. So game is clear, right? I give you 2 numbers, right? Any 2 rows. I must tell you where the sum is, right? No, that's what I want. I want to think about. I want a row also in 2 different rows. I want to just no. It's an imperfect game in some sense. Just by the sum, can you tell me which row the sum will land in? Okay. You give the row numbers and the 2 numbers. The information is given to you. Okay. But without looking at the calendar, can you tell me where the sum will land? Inshallah, anything you want to take. But I'm saying, my claim is that if I know the 2 numbers and the sum, I can find where the row is, right? So let's say I give you an example, okay? So let's say, I'll give you all the data. Let's say, okay, let's go. I give you row 1. I give you row 1, right? I'll take row 2, right? I pick 7 and I pick 8, right? 7 place 15. Where does it land? It lands in this row, right? So so is this, just check what's going on. So I wanted to see what pattern is happening. Okay? Yeah. Finally, somebody. Very good. Tell me. I'll listen to you. Very good. Let's do. Okay. Let's do. Okay. Very good. See, this is what he wants to do. Let's do that. Okay. So the person said they want to index the thing as row 0 for Sunday, row 1 for Monday. Very good. Let's do that. Let's write my thoughts down. Row 0, row 1, row 2, row 3, right? Row 4, row 5, and row 6, right? My handwriting is a bit off, but this is what it is. Okay, very good. Right, now what next tell me? So a lot of things, huh? Okay. So the person said, let's do examples. Examples first, huh? So let's say I take row 0 and row 1. If I add it, right, I get it in row 1 again, right? So the sum lands here, right? Okay. But then can you find 2 rows where the sum doesn't land in that row? Auntie, tell me, 9 and 10. Very good. So the person took the next one was the person took the following. Take this row, right? Take 9 and then take 10, right? So 2 plus 3 lands in. Correct? Very good. So what's happening now again? So it's just sum of the rows so far, right? So now we figure out here it's 0 plus 1 is 1, 2 plus 3 is 5, okay? So now we've got one step ahead. We think the sum of the two numbers will be the sum of the rows, okay? Can you find an example where this also fails? Let's say 5 and 6, let's go, very good. Let's see, last part, we'll stick, okay? So 5, let's go 5. Which one do you want to take? No, what numbers? Oh, there you go, 5, very good, thank you, sorry. My bad. So 5, very good, thank you, 5. And write your thoughts down, no writing thoughts down, no, okay. 5 and 6, where does sum land? 11, right? 11. Why is that, tell me?
Because, sir, corresponding to that, sir, for example, if you take row 6, sir, when you go back to
Auntie.
row 0,
Yeah. So
0 is row 7.
the idea is that what the gentleman said was some mod whatever, right? What is mod? Remainder, right? So you add the 2 rows, divide by 7, whatever remainder you get, that's where you land, okay? That's the answer for the game, okay? Auntie, you have spoken once, so we relax. No. Tell me. Who's telling me? Let's go. Okay, so the idea is the location game is that you take the 2 rows, right? What's the answer? What's the answer we get? So you take a number in row. See, this is how you write the answer down. Take a number in row X, right? Let's call the number A. B number. I'll write down the whole thing. Since you're not writing thoughts down, let me write thoughts down. Okay. So, right. So take a number in row X. Let's call it A, right? Take a number in row B, right? Row Y, call it B, right? You can do anything. You can choose any number you want, A or B, regardless of A or B. That's crucial. Regardless of the value A or B. Of course, as long as A plus B is less than or equal to 30, right? The sum will lie in row X plus Y, or let's say row R. And what is R? R is the remainder of X plus Y divided by 7. Okay. I don't want to use mod or terminology like that, but that's what's happening, right? So the crucial thing about a calendar is the remainder by 7, right? When you divide by 7, the remainder. That's something we're getting to, okay? Very good. This is how you write thoughts down, okay? Right? Like I wouldn't know, okay. Yeah, tell me.
What about 5 and 6?
Yeah, sorry. So what is row 5? Very good. Let's see. Row 5 and row 6, right?
No, the numbers 5 and 6.
Yeah. So 5 plus 6 is 11. So 11 lies in row 4, right? I make many mistakes, but this is not one of them. Okay. Let's go. See again, this is modulo, goodulo, don't do. Do what I'm saying. No, remainder by. I've written the whole English. No. I've said no. What I've written English. No. Read English. No. Second, you must resist terminology, right? Little bit. Huh? It may help you in many things, but understanding, you must understand exactly what's going on, right? When you can. It'll be more creative. Okay. Now let's go. We have 13 minutes left. I want to finish 4, 5, and 6. Let's go 4. Quickly, 4. Remainder? Yeah. I say R row, no. Some in line row R, where R is remainder. Auntie. Aunties. 2 aunties. Let's go. Number 4. Let's go. You want calendar, right? Let's go. Okay. So I'll leave the calendar on the board. Huh? Let's go. The calendar is here. Play this second one. Remainder idea. Right. Very good. So what's the question again? Let me see the question. Okay. Right. So the question says it correctly, right? So, right. If I pick a row, pick a number, the remainder of the number divided by 7 is what? Index of the row, right? Very clear, right? The way I've done it, right? So like that person helped me out. Oh, champion gone. So very cool. So now, if I divide any number here by 7, I get remainder. Divide anybody by 7, what do I get? Row number, right? So these row numbers are the remainder of each number divided by 7, right? That's how I've rigged it, right? Okay, very good. The next one is, remainder number divided by 7. Okay. Very good. So the answer is, the remainder is the row number, right? So the remainder is very good. Okay. Now let's say naming of the day. Number 5. Why is that the case? Can someone tell me? 10 days after April 9th is the same day of the week as 3 days after 9th April. Why is that? Right. Have you written it down? Write the whole thing down. I'll come and check. Write the whole thing down. I'll come and check. That's clear, right? Our week repeats by 7 days. Of course, I would always like a Sunday repeat a Sunday, but it doesn't happen. After Sunday, Monday comes. So every 7th day is same day of the week. So that's why the 10 days after that is the same as 3 days after that, right? Very good. Yeah, exactly. Try. Okay, forget. I'll correct him here. You focus on the worksheet here. I'll correct him here. Let's go. Okay. Can someone solve this now? How do you solve this now? You divide 389 by 7. Whatever remainder you get, those many days you add to the day, right? Do that. Let's see how much you get. Let's see. Tell me. Write down. Champion, you got to write down. Write down. Nothing written down. The 2 words. Write thoughts down. 2 words. What's no? Tell me. That's right. So very good question. Someone asked me a question. First question. Very good. First question. They say some leap year happens. Is division by 7 okay? My claim is it's okay. Can someone quantify why it's okay? Someone has not spoken so far. Why is it okay? It doesn't matter next year leap year or not. I'm okay. Because, why is that? Because a Monday repeats a Monday 7 days, right? There's no problem. So I keep counting 7, 7, 7, doesn't matter. So it doesn't matter next year leap year, not leap year, doesn't matter for this calculation.
Usually, I check my birthdays every year, sir, but it will skip like one day. It's date dependent, not date dependent.
That's right. It's day dependent, but I'm looking only day, right? Not date. I'm looking only day, right? I'm not looking at what date that day is. I'm not done that yet. I'm just looking at what day it is. Today is Wednesday, 389 days from now, what day it is, right? Not date. Date it will matter for sure. You understand the argument she's making? Right? So if you want, if I ask you what date, so for example, here, this is cool to see. If I ask you what date it is, then leap year will matter. Okay. Day doesn't matter. Okay, what day is 389? Tell me, some calculate, tell me. Saturday, very good. So 389 by 7 is, what is it? No, what is it? 55? No, 55 plus 4 is it? No. So 7 into 55 is it? Plus 4, is it correct? 35, 3, correct, very good. So remainder is 4, so that means this implies, so I go Wednesday is today, that is, next is Thursday, Friday, Saturday, right? Tuesday, I know, Wednesday is day 1, right? So Saturday, correct? Very nice, okay. Okay. So now let's do 6. Let's take 5 minutes, think about how we'll do 6. I'll close this. Good question. So I could ask question 6. I was asked a question in my 12th class when I was doing computer long time back. I don't know what the shit was going on. I did mod and all, but mod God I did some program. But the understanding is quite cool, right? All you have to do is remainder by 7. That's it. Nothing else, right? How do you write it now? Tell me. If I want to write the calendar, let's say I give a specific year. Let's do so 2045. Or let's say 100 independence, 2047. How will I write? What will you do first thing? We have 5 minutes, so let's just discuss. So suppose you want to write a calendar, what do you need to know? What is the day corresponding to January 1st, right? That's what I would do, right? So now, first question is, what is, let's do example, what is the day of January 1st, 1947, right? How will I find that now, given what's in the worksheet? What will you do? 24, sorry, 91 is independence, sorry, 100 years, sorry. How will I do? What's the first thing I have to do? How do I find the day? To do this, if I go to question number 5, how will I use that? Tell me. What's the first thing I have to do? What will I divide by 7? What will I divide by 7? How do you find the reference? I'm asking. No, you just have to find the number of days from today till January 1, right? If I know that, I'm done, right? Because this question tells you how to do that, right? If I know the number of days from a certain date and a day, I know the day of that day, right? So all I have to do is, from today, I have to find out how many days are there till January 1, 2047. There now, leap year, everything will come in now. Okay. So let's do calculation now. So now, to do this, I need to question tilde, right? See, if you didn't get the answer, I want you to write thoughts down. I do not know how to do. Siva explained to me. Find number. Write it down. Write thoughts down. Yeah, write down. Okay. So question tilde is the following. Now, here. So second thing is, to answer this, to answer Q, we can use 5. You need to find the number of days from today till Jan 1, 247. Can someone do that for me? How do you do that? Is today a leap year? This year leap year? Next year? So let's what year are we in? We are in 2026, right? And what date? 8th May, right? And that's a Friday. Very good, right? 27 is leap year? Huh? 28 leap year. So 27 leap year, then 28, right? Now, and you have to go till 2047, right? So each year, how many days are there? Very good. So this 365 here, right? How many days are left this year? Count, let's say count. Write thoughts down, yeah. Auntie. Huh? Huh? No, today is the 0th day, right? From today, right? So that's what it here, right? This question. So 5 leap years you'll have. Very good. That's a good correction. How, because AP by 4, right? Subtract the 2 terms, 5 you get 5 leap years. Yeah. So you have 5 leap years, right? So you have 5 leap years. And how many other years? How many other years there? 5 leap years. How many other years left? 14, right? Huh? 14 normal years. Correct? Oh, 30 normal years, I'm not sure. 14, right? So you have 5 leap years, right? You start 2027 and then 15 leap years or 14 normal years, let's see. 15 more years, right? So 15 normal years. So you have 5 leap years and 15 normal years, right? And this year you have so many days, right? This year you have how many days you have checked. Quickly, somebody. And 2026, how many do you have? So calculator, anybody has calculator? 5 into 366, 15 into 365. This year we have what? June 30, July 31, 61. Okay, let's see. So June, July, August, September, October, November, December. So July, September, November is 90 and are 31. How many do you have? Tell me. Huh?
20 into 365 minus leap year 5 days plus that.
Plus 5. Huh? Why 90?
No, 15 is normal. அது தவிர you have this 5 into 3. So it is 16, 20 da. So 20 into 365 plus you add 5.
I can do that also if you want. Yeah, I can do that. Okay, this part is easy. Someone said that to do this, you do 20 into 365 plus 5. Tell me. This year. Very good. Okay. Huh? Don't include today. Yeah. Today is 0. Yeah. So what is this orange one? Huh? Thank you, auntie. 7,000. So you add. Then you add the brown and the orange. What do you get?
For these 20 years.
What do you get if you add these two?
Complete this year.
Somebody help me. Huh?
This year is
What do I get? 7,500. If you divide by 7, what remainder? If you divide this by 7, what remainder you get? What do I get? Huh? The remainder 7? What's the remainder? 3. 3. That means the first January, for example, what now? Saturday, Sunday, Monday. On our way. Calendar. Okay. Good. Very good. So now the idea was suppose somebody had told you, hey, write the calendar. You think it's an enormous task in your head, right? Like. Yeah, there are many other sub tricks to it. I understand. Yeah. Auntie. That's what I didn't know. 237. I don't know. 237 plus 7305, 7342, right? 7542. 7542, sorry. Yeah, I'm okay. Okay, very good. We'll take a 5-minute break. We'll come into something else after that, something different. Okay, very good.